Okay, we're asked to find the slope of the rational function y equals 1 over x at the point 1, comma 1. So we're going to use the definition of slope, and our function f of x is 1 over x, and the constant for which we are taking the constant, so c, is 1. When x equals 1 is what we're looking at, where the slope should be. So the definition of the slope is f of the constant 1 plus delta x minus f of 1 all over 1 plus delta x minus 1. And then we take the limit. I didn't give myself enough space. Sorry, I'll just erase that. And then we take the limit of this slope as delta x goes to 0. So remember, this is the change in the y coordinates over the change in the x coordinates, and then immediately those ones cancel out. So this, for this particular function, is going to be, so everywhere I had an x, it's going to go in the denominator because my function is 1 over x. So f of 1 plus delta x is 1 over 1 plus delta x, minus 1 over 1 is 1, or I can just take that from my y coordinate, and this is all over delta x. Now notice that direct substitution, if I put 0 in for delta x in both places, I'd get 1 minus 1, or 0 over 0. So that's indeterminate form, and we need to do some algebra to manipulate this. Now, we haven't done much with fractions yet, but if you have fractions and you want to try to subtract two fractions, we know from middle school that to subtract two fractions, we need a common denominator. So I need to make both of these fractions have the common denominator of 1 plus delta x. So what I'm going to do is multiply this second term by 1 plus delta x over 1 plus delta x. Now, of course, I can multiply by something like that because it's just equivalent to 1. So that gives me my first term, 1 over 1 plus delta x, minus 1 plus delta x over 1 plus delta x. And now these both have the same denominator, and I can actually subtract, right? When I subtract, I have to remember that this subtracting is happening to the entire numerator here. Okay, so what I'm going to get, so I have the limit as delta x goes to 0. By the way, notice that I am writing this limit every single time, even though it's notationally sort of annoying. But that's because in order for these equal signs to actually be equal, at some point along the way, this limit has to be written. And if I don't, it's not correct. Okay, so I'm subtracting now this fraction minus this fraction. So I'm doing 1 minus the quantity 1 plus delta x. So 1 minus the 1, but also minus the delta x. Right, so I'm distributing that subtraction. And this is all over 1 plus delta x. And then the whole thing is all over delta x. So I have a fraction within a fraction. So in some sense, what I have is like a divided by b over some c. So I want to use another fact from middle school, which is if you're dividing two fractions, right, I can think of this as like a c over 1. If I'm dividing two fractions, or written another way, a over b divided by c over 1, hopefully from middle school you remember that that's the same thing as a over b times 1 over c. Okay, so in this problem, this a, b, c, and d, the a is this complicated numerator. This is my b. This is my c, and then over 1. So the point of this whole thing is that I can combine my two denominators, right? I can bring this delta x up. Okay, so all of this middle school fraction common sense tells me that this is the same thing as the limit as delta x goes to 0 of, oh, let's go ahead and cancel 1 minus 1. It's going to be negative delta x over the 1 plus delta x, right? But I can bring this delta x up into the denominator, right? Because what's really happening is just like here, right? This c, remember a over b divided by c over 1, the c is equivalent in the denominator of with this b here. I don't think I said that very well. Hopefully you followed. Okay, so here's the point where we need this limit, right? I have a delta x over a delta x. I can cancel those as long as I have this little caveat here that I write the limit out front, because these are only equal if I continue to write that limit. So I'm left with negative 1 over 1 plus delta x. And now finally, as delta x goes to 0, right, this goes to 0, I'm left with negative 1. So my slope is negative 1. Okay, we found the slope. That's great. Now they want us to write an equation for the line tangent. Okay, so I have the slope is -1. I'm given a point 1 comma 1, so I'm going to use point slope form of a line, and my equation is going to be 1y minus the y coordinate equals the slope times x minus the x coordinate. And there's my line. Okay, we are asked to also confirm by graphing the tangent line. So I'm going to go ahead and pull up Desmos here. Let me squish this over a little bit so you can see. So here is our function. Here is the point 1, 1. Let's go ahead and graph that line. Y minus 1 equals -1 times x minus 1. And there it is. And sure enough, that does look tangent. And by the way, if you prefer the slope-intercept form, that would be y equals, if you simplify and bring the -1 over, it would be y equals -x plus 2. So if I graph that, y equals -x plus 2, you'll see that's the same line as well. So either of those would be the line that's tangent to the function at this point.